Okay, so today we're gonna talk about two parts, and we're gonna mainly majorly focused on the DJI Air 1. Things that you guys all know that we officially start to take orders from the beginning of this week. So it's about time. We need to refresh the products and also deliver you guys the solutions of how to use it. So DJI L1, so we're gonna divide it into the two parts. Also, as I forgot to mention, the second part is the DJI Terra, the latest functionalities. So the DJI L1, we're gonna mainly talk about for the two parts. One is the product introduction, the second is the applications and case studies. So for the product introduction, so DJI L1, again, it's the highly integrated system, efficient, easy to use enterprise aerial lidar payloads. So it combined with the Livox lidar sensor, aerial surveying and mapping grid camera, and also a auxiliary vision sensor and a high precision IMU system all in one. Highly integrated solutions. So combining with the M300 RTK and DJI Terra, and DJI L1 provides highly efficient all-in-one solutions. And it's a perfect tool for energy inspections and AEC, forestries, and public safeties. This is the, go back to LiDAR principles, and basically that's how LiDAR works. So in most cases, it's really simple, right? So it, basically it emit the pulse, hit the targets and return. Then it will calculate the distance. So that's basically how LiDAR works. And on the upper right corner, so this animation shows that how L1, the LiDAR sensor, works internally of this structure. So this is L1 sensor. Wait, hold on one second. What's going on there? So you guys, sorry. So this is the L1 sensor, and basically it emit a pulse, then it hit it, and we can change the mirror to different directions, and it will spread to different areas. So that's basically how that works. So the DJI L1 sensor, like I said, it's combining with different parts like 3-axis gimbal. So this is the first LiDAR sensor that has the gimbal system. So the huge advantage for that is if you're talking about to do the, for example, like a side wall or mountain, side of the mountain inspections, you're able to change the angle to scan it, towards to the side of the wall. But other, like in the past, other sensor that they are basically a fixed angle, which is near to the ground. So it really limits, the potentials and scenarios and applications for it. And also we're combining with the high precision IMU systems and LiDAR sensor, 1-inch camera, and auxiliary vision sensor. So you're able to capture the images and LiDAR data simultaneously at the same time. So the point cloud density is another very powerful advantage for this sensor. So over 240,000 effective points per second, and it supports 3 returns. Per flight, it can cover up to 2 kilometer square meter area. And accuracy, we're able to achieve vertical 5 centimeter accuracy and horizontal 10 centimeter accuracy as well. All the functions that for L1, so when you purchase L1 and collect the data can be processed in DJI Terra, and it's actually a fundamental functions in DJI Terra. Means that if customer, they purchase L1 and then they just simply need to download DJI Terra from our website, and then they can use it to process the LiDAR data. There is no need to purchase extra license for it. For the LiDAR sensor, only one function called LPP, and that's actually to improve the relative accuracy of the different the flat paths, the belt area, the edges, to give you a better accuracy. So that is actually included in DJI Terra Pro and electricity version. But you are able to achieve the promised accuracy, which is you can refer that from our website with all LPP functionalities as well. So that's pretty much how that works for the L1 sensor. Let me check again. Are you guys able to see my screen and hear my voice okay? Because from my side, it seems like I dropped it for like maybe like 2 or 3 seconds. Want to make sure you guys can hear and see my screen. Okay, cool. This page basically tells you that there are 2 ways to use the L1 sensor. We have 2 a different method to scan data. One is called repetitive pedal scan, and that's how that looks like in the first screen. And this is called a line scan, which is the repetitive scan. 2 patterns. So people may ask, when do I have to apply non-repetitive pedal scan, and when do I have to use the repetitive scan? So in simple words, if you're looking at to have a better accuracy, so you always apply to the repetitive scan, so which is the second one. So the advantage of that is because in that case, it actually has a like smaller FOVs in the the vertical areas. So in that case, when you do the scan, it will repeat at the same area like multiple times, and also have less distortion as well. That's why you can promise and deliver the better accuracy. But when do you use the non-repetitive pedal scan is when you care about efficiency, and also when you do the, for example, like the side of the wall scan, and especially you're going to the vertical directions, then you will use the non-repetitive scan. So to give you a better and broader view of the FOV. So that's how you select from it. And this page basically tells you the reflectivities of the L1 sensor, and those are some the physical components like the desert and the white dry grasses and wet grasses, all the reflectivities in there. So in most cases, because let's see, most of the objects in the Earth are really above or near the 10% reflectivities. So we're able to measure the distance up to 190 meters at 10% reflectivities, okay? So this is the basic principles of the DJI L1. So it supports 3 returns. So the advantage of the 3 returns is that actually give you more information. For example, if we're trying to do the scan of the forestry, and if we're trying to do the scan on the area that is covered by different structures, by having different returns, we are able to get information. For example, the top of the trees and structure of the trees, and also the ground informations by different returns. Then we are able to classify and categorize the DEM, DSM, and the vegetation height, and the tropical rainforest structured inside of it. So the camera module. So in simple words, that the camera, it's the same camera that the Phantom 4 RTK has. So it's surveying and mapping level graded camera. So there are 2 options to use it. And option 1 is you can use the camera with the LiDAR sensor simultaneously to use the camera to capture images. So when you're post-processing the data in the DJI Terra, you're able to use the informations and color in the images to colorize the point cloud data. So in this case, there is no need to set very high side and front overlaps. So most of the cases, just leave as default settings in DJI Pilot. That should be enough. And second options is that people always asking is, are we able to only use the camera but not use LiDAR data, LiDAR sensor? Yes, you're able to use that. So there is a function in DJI Terra. You can only use the camera and do not use the LiDAR sensor. So in that case, you need to set the overlap of the camera sensor just like what you did in the Phantom 4TK. So, and this is the accuracy parameters that we can deliver. So IMU accuracy, for example, like we're able to achieve like yaw pitch U roll at like 0.3 degrees and 0.05 degrees in the net RTK models, and we're able to achieve like 0.18 degrees and 0.18 degrees and also 0.025 degrees for the pitch and roll the angles as well. So when talking about, but in most cases, right? So we're talking about like the general like system like performance, the accuracy, not only just the LiDAR, not only just the IMU. So in that case, like system like relative accuracy, we're able to achieve like 10 centimeters at 50 meters, relatively high above the ground. And we're able to achieve like 5 centimeter accuracy at 50 meters in the PPK mode. So for the absolute accuracy, we're able to achieve 10 centimeters at 50 meters in the PPK mode. So point cloud density is roughly around like 100 to 300 like points per meter square. And we recommend the fly height is around 50 to 100 meters. And another exciting part is that DJI L1 is officially supporting the PPK functionalities. Means that you are able to do the PPK processing in DJI Terra for L1, and I will introduce that later on to you guys. So the point cloud live views, and this is in DJI Pilot. So how that works is, while you were planning the missions in DJI Pilots, while the drone was flying and capturing the data, in DJI Pilots, you are able to see the area of the LiDAR data simultaneously. So that will give you a better view and better sense on how the land surface looks like, and give you some on-site informations to help you guys to make some emergency decisions where we're going to go and how that surface looks like. So basically, when you perform the LiDAR missions in DJI Pilots, and that will be how that looks like, just like the videos I showed to you guys. Okay. So we're talking about IMU calibrations. So if you guys had some aerial LiDAR user experiences in the past, so most cases that you guys are familiar with the IMU calibrations. So in the past, this is very complicated and very hard to achieve in a good way procedures. But now it doesn't like that anymore for DJI L1 sensor. So we actually have the IMU calibrations automated in DJI Pilots. Means that when you perform the missions, and it will automatically to perform the IMU calibrations. Okay. So basically, the most important part is that you guys need to remember that the accuracy of the IMU system will continue to be lost during the uniform flight of the aircraft. As far as the L1 is concerned, so 100 seconds is a crucial time for us. So 100 seconds of the constant flight, the accuracy of the IMU system will drop below the nominal accuracy. So the IMU calibration means that the IMU can be restored through large speed changes to higher level of the accuracy. So option 1 would do the RMU calibration is we accelerate and then we deaccelerate to give them to give the RMU system a different speed and make sure that they can calibrate it by themselves. And second way that also is built into the DJI Terra is called a figure 8. By performing the figure 8 and also do the jobs to calibrate the RMU system. So in the aerial photography missions, for example, we're talking about aerial mappings. The calibrate flight bottom is turned on by default. So when you set up the missions and start the missions in the beginning, and it will start the RMU calibrations. So in the aerial map missions, so the RMU method, calibration method, is to do the accelerations and deaccelerations. So you will see that the aircraft perform accelerations and deaccelerations, like friction back and forth like a couple times, and then will be automatically carried out. Then you should be good. Okay. For case, for example, like corridor mapping, the flight calibration flight bottom is turned on by default as well. But in that case, the drone will automatically perform a figure 8 calibrations, just like what we draw in the bottom of this slide. So the drone will perform a figure 8 to fly to calibrate the RMU. So, but when you perform, for example, like the manual flights, because this is the manual flight, so there is no options to do the automatic RMU calibrations. But in the DJI pilots, on the left upper corner, you're going to see a figure 8 calibration buttons. So if you're going to do the manual flight, make sure that you click it and to do the calibrations. Okay. So another part what I want to mention is in this slide, I mentioned that 100 seconds, right? So in most cases that we recommend that a user to fly the LiDAR sensor above 10 meters per second and below 15 meters per second. In most cases, it's 10 meters per second. So let's see if we fly 10 meters per second, and also we count for 100 seconds. So that means if the single flat pass is longer than 1 kilometers, so I have to perform a RMU calibrations in order that I can keep the accuracy always at the same level. So that's how that being calculated, okay? So when you perform the manual flights, so that's going to be always the cases. Make sure that you do the calibrations. If your flight speed is at like 10 meters per second, you do the RMU calibrations every kilometers. But if you, for example, perform a mission flight, so for now, there are a couple suggestions. Suggestion 1 is for now, make sure that the single flat pass. But for example, if the flight is an adjacent flat pass over 1 kilometer, that's okay because there is already a turn, and that's actually calibrates the RMU system. But if the single flat pass longer than 1 kilometers, make sure that you need to either force the drones and click the RMU calibrations to perform one RMU calibrations, then keep flying the data, or simply make sure that the mission area is the single flat pass is less than 1 kilometers. And in the next firmware updates, maybe roughly going to be around let's see, late June or beginning of the July. So you can plan a bigger missions in that case if the area, so we're going to based on your flight speed, and we're going to based on the timings. So the DJI pilots will automatically calculate where you need to perform a RMU calibration. So that will be ready in our next official updates. So for now, make sure that you do keep that in mind, okay? So this is the case for the aerial mapping. So now you see that lines, there are yellow areas in the edges, and also there are like green lines. So in simple words, that the yellow lines will not collect the data, and the start points and the end points that will perform the accelerations and deaccelerations to calibrate the RMU system. So this is second options in DJI pilots, corridor mapping and oblique mapping. So in that case, you see that there are like a figure 8 calibrations in the end and in the beginnings, and that's where you're going to do the calibrations as well. So this page is really important. Okay, so this is the recommended flight parameters for the DJI L1s. So right now, the default and the only apps that right now can control the DJI L1 is DJI Pilot. So there are several options that you can perform and collect the data by using DJI L1. Manual flights, waypoint, aero mapping, oblique, and linear flights. So pre-flight, okay? So turn on the M300 and L1 first and wait for 5 minutes on the ground to warm up the system. So once the system is ready to go, and it will pop up a message and it tells you that warm up is finished, then you're good to go. Make sure you wait until you get that message. And RMU calibration, manual flights, and waypoint missions needs to manually perform figure 8 calibrations like I mentioned in the previously, okay? And camera settings, RGB camera, we recommend always to put it into the S mode and put the shutter power artist at 1/2000 and make sure it's at MF manual focus, okay? So there is also options like I mentioned previously as well. If you want to use the L1 only as just like the Phantom 4TK, make sure that you select L1 photogrammetry, so that will turn off the LiDAR sensor and only perform as a camera. Returns, couple options here, single, multiple, and 3 returns. So that should give you more options to choose from it. And colorized model. So make sure to turn on the colorized model to have RGB images for LiDAR mission. Otherwise, if you do not turn it on by default, you're going to only have the LiDAR data, but no RGB images, okay? So also returns. In the following slides, I will also let you guys know what's the best practice to select like a single return, multiple return, 3 returns. Flight height. So flight height, we recommend that if you perform the real-time point cloud data, we recommend that you fly around 50 meters. But in most cases, 100 and also maybe a little bit above, like to 120 should be okay, that you perform the actual missions. And in most cases, 10 meters per second is the ideal speed that you fly the L1. So that's the parameters and recommendations from DJI. So those are some sample cases that, so those recommended parameters, it's just, from our, you can use that as a reference because in different area, different weather, different landscape and land surface that may have different scenarios. So it cannot be always applied to all the scenarios like 100% of the time. But those recommended parameters, it's where you guys can set it in the beginning and use that as a reference. Then you can adjust it based on that reference. So in our experiences, for example, if you're planning to do the topography map, then we recommend that you can start to try it at flight height around like 100 meters and flight speed around like 10 meters per second. And set overlap rate set to 50%, number of echoes, 3 returns. So why it's 3 returns is because in the topography, landscape, land surfaces, it's not like always like a barren grounds, and it has covered by, for example, like grass and trees and vegetations and towers and buildings and things like that. So by having different returns, then you're able to get different structures and surface of that area. So in the end, you're able to use those informations to categorize like DEM, DSM, and contours and those type of information, okay? So scan mode choose the repeat scan, like repetitive scan mode, because in this case that we're able to deliver the best accuracy. So, but I would say most of the time, if you need a true color, which is the most cases, make sure that the visible light camera is turned on. So another one is forestry mapping scenarios. So in this case, there are several suggestions, right? One is we use the aerial mapping, but make sure that we have the terrain follow functions if needed, right? So one tricky parts that I want to let you guys know is right now you are not able to perform the IMU calibrations and a terrain follow like simultaneously. So in that case, what I would suggest that is you do the manual calibration first, then you start the mission with the the terrain follow DSM information like inserted and imported into DJI Terra. Then you perform a terrain follow. After the mission is finished, then you manually perform another IMU calibrations again if you're gonna use the terrain follow. But in most cases, if the surface is flat, not having a lot like fluctuate changes, there is no need to use terrain follow. Simply use the aerial mapping, then you should be good to go. And flight height in this case, you can set from 100 to 150 meters, 50% overlap, and 3 returns because it's the same case and lot covers by trees and vegetations. So by having that returns, we're able to define and categorize different information. Scan mode again, repeat. Make sure you turn on the visible light if you want to have the true color information as well. So, and this is another scenario for the power line mapping. So in this case, there are some very interesting points compared with the previous scenario. So first of all, the power line is the linear patterns. So make sure that when you use DJI Terra pilots to choose the linear flights. And also there are 2 options, right? One is that you can simply import a KML into the DJI pilots, then it will based on the KMLs to automatically and intelligently calculate the flight paths. Okay. Second way is you can always manually to fly the M300 RTKs to the each top of the towers and set the point. Then a pilot will, based on the points where you set it, to automatically and intelligently generate a flat path for it. So make sure that flight height is 50 meters, okay, above the top of the ground. So it's not above 50 meters of your relative height. It's always 50 meters relatively above the edge towers. So in that case, you need to make sure that you have the correct height information of each tower. So in that case, depends, right? So if there is not a lot, vegetation coverage, so just the barren ground and towers and lawns and 2 returns is enough. So in that case, you can choose non-repetitive scan because in most cases, the power line inspections is not like topographies and aerial survey and mapping secure the accuracy that sensitive. So by having the non-repetitive scan, that will give you more, efficiency to have the data ready to go. So this is another case. It's the city modeling, right? So city modeling. In this case, that we recommend that you choose the oblique missions. So why? Because if we don't use the oblique missions, the camera is always, the L1 sensor is always like facing down to the ground. So it will lake off the side of the walls and other detailed information of the buildings. So by performing the oblique missions, we're able to capture more side and other angles information of the area. So always make sure that we use oblique missions when we're performing a city modelings. But in this case, 4 oblique missions is enough. It's not really important that we have the nadir one as well. So measurement area size, make sure, like I said, if we use the fly speed is around 10 meters per second, make sure that each adjacent flat path do not exist over like 1 kilometers, okay? So the scan mode depends, right? So it depends. If we're talking about efficiency, if we're talking about, relatively, for example, like I said, the side informations of the walls, and we choose the non-repetitive. But if we really care about like the flat accuracy, so we can choose the repeat scan. But in most cases, if we're talking about like the side of the walls and other side informations, non-repetitive scan is always going to be a good option for it. And gimbal angles that we can select from -60 to 45, so that should be okay. And those are just some experiences by ourselves. It's not like I tell you have to do this. It's really just give you guys a reference point. There you can start to try to adjust the parameters based on this reference. So that should give you a good help and hands-on on that. So Terra also support different results like true color, reflectancy, elevations, and returns from DJI Terra. And right now in DJI Terra, we are able to process the L1 data, and there are basically two steps. Step one is we can use DJI Terra to output a middle results. So what I mean by middle results is that simply you import the raw LiDAR data and other information, like for example, like IMU information and RTK base station data. Then you can output a raw LiDAR data with a high precision post data as SBET formats. So these middle results are actually for developers that they want to use it as a resources and to develop their own algorithms or software to produce the point cloud data. In most cases, our customers, and you guys shouldn't be worried that too much. And second step is that you are able to use DJI Terra to produce the finalized true color, reflectancy, elevation, and returns high quality LAS file. Then you can use that LAS file and import into a third-party software, for example, like TerraSolid, and to perform more vertical analysis, for example, like contours and DEMs and classifications and etc. And also in DJI Terra, you're able to do the measurements for the point, linear, area, and volumetric as well. So for the post-processing, and that's how that looks like. So on the right side, and DJI Terra interface, and I will show you guys later on as well. So you're gonna see the options very, very simple. So you simply import the mission folder. Then you select the qualities of your point cloud density. So you can choose from high, medium, and low. So the high, it's actually at its original resolutions, and median is actually at 1/4, and low it's around 120. So it's really just give you sparse point clouds. But because of the L1 sensor can produce pretty dense point cloud data, so in most cases that should be okay. So it really depends on the results that you need and efficiency that you care. You can select point cloud densities in different level. The point cloud effective distance is, for example, like in the beginning, what I mentioned is at 10% reflectivities that L1 sensor are able to detect up to 190 points, as we promised. But sometimes there maybe have some points that can over that distance. So we give that a little bit buffer. And for example, by default, it's set up to 250 meters. So in most cases, that should be okay. We don't have to change it. So what I mean is, if Terra detects any points that is over 250 points, 250 meters, and DJI Terra will consider that as a noise and eliminates it from it. So that's how that number means. Okay. So DJI Terra supports L1 LiDAR data. The processing and output results are LiDAR point cloud files such as LAS. The point cloud accuracy optimization function can improve the relative accuracy of the L1 modeling, and these functions require the support of the professional pro version and above, which is electricity version. Okay, so in the right side you see the optimized point cloud accuracy. So this is a paid function in the pro and electricity version, but however, for now, right now, when you guys purchase the L1 to the customers, when customer get the L1 sensor, so in that hard case, that they will get a physical cards, and that's actually a 6 months free trial of DJI Terra electricity version that customer can use it to try it. And the major difference between the free version of DJI Terra and also the pro and electricity version is that pro and electricity versions can also perform the photogrammetry analysis. For example, that they are able to process the images from Phantom 4TK from DJI P1 and to use the photogrammetry ways to generate the results. But if you guys just simply directly download the Terra from our website, you have to pay for photogrammetry functions. That's the difference of it. Okay. Also, the point optimized the point cloud accuracy and these functions, because it already gave them a 6 months free trial, so they can use it. But after 6 months free trial, this function will be disabled. So if customer wanna use these functions, they need to upgrade it to the pro and electricity version. And also, like I said, even we do not turn it on, we are still able to deliver the accuracy as what we promised on our website. So that's the key there. So by turning it on, it will increase the relative accuracy of the different flat paths and edge areas, make sure that there is no redundant data, and make sure that we can reduce the noise at the edges area. So this is how that looks like. So when you open the DJI Terra, make sure that you download the latest version of DJI Terra from our websites. So you're gonna see 2D map, 2D multispectral, 3D model, and LiDAR point cloud processings. So then you select the coordinate system based on your localized information. Then once you open the mission folder, you're gonna see the raw files and images, and I will show you guys later on how to import it as well. Very easy. So this page is the explanations of the what inside of the mission folder, right? So first, we're gonna have a file called CLC file. So this is the LiDAR camera calibration data. Second one is the LiDAR IMU calibration data. And third one is the visual calibration data. Fourth one is IMU data, then it's raw LiDAR data, visual data, RTK base data, RTK antenna data master, ARM data, RTK antenna data slave, and images. So make sure that when you collect the data, because sometimes that if SD card is not the high-speed SD card, and it may missing recording some key components. So make sure you check the folders and having all the information that are listed in these pictures, and then the Terra are able to process it. And most important part is what I highlighted in the red. It's called RTK base data. This is really important. If you do not have the RTK base data, DJI Terra are not able to process the LiDAR data 100% of the time. And also make sure that the RTK base data is at correct formats and protocols if you are choosing to use the net RTK, and which I will explain later on. So when we're talking about DJI Terra post-processing parts, and especially for the PPKs, So in simple words, right now in DJI Terra, the L1 is the only payloads we are able to use DJI Terra to perform a post-processing procedures for now, okay? So how that works is, first of all, we use the DJI Terra to process the L1 data, make sure that the base station data must be available for the solution to be successful. And when do I use it? Is sometimes when the net RTK signal is too poor, area is too complicated, and there is a strong, like for example, like magnetic interference. So always perform the PPK methods. And there are two options to do it. Option one is simply use the DRTK 2.0. And option two is you can use the third-party base station, which can generate the corresponding and correct format of data like RTCM data, RANEX data. Then you are able to use the observation data from third-party base station and import to DJI Terra to process it as well. Okay, so how to do it is, first of all, confirm the time period of your tasks. Make sure that the point cloud data is always corresponding to your observation data from the base station, and observation data from the base station should be longer than the actual point cloud flight data. So for the DRTK 2.0, for example, you search the RTCM files at the DAT formats, which store in DRTK 2.0 mobile station, or maybe the third-party RTK base station in the same time period. Then you need to rename the corresponding RTCM file to a file with suffix at RTB. So in the previous page, you see the end surface called RTB. Make sure that you rename and make sure the suffix at it's the same like RTB. And copy it into the post-processing folder. Make sure that you put it into this folder. Then if there are multiple DAT files, especially from what I mean is from the DRTK 2.0, simply just put it into the folder and that's okay. The DJI Terras are able to detect the different DAT files and make sure they can merge that into the same name and to process it. And one note, please make sure that time in the RTCM file, which is stored in the DRTK 2.0 mobile station, is at UTC format, okay? So maybe you need to do some conversions for the timing as well. So this is really important. The right side, the formats and protocols are really important. So many of you guys have already got your L1 sensor on your hands, and within last couple of days, we had experienced a lot of feedbacks from our overseas channel partners that they basically told me that they are not able to process the data in DJI Terra, and it always gives them and returns a post data error. So what happened is because one, they used the net RTKs to perform the missions. It's not like the net RTK is not okay. We actually support the net RTKs. There is no difference. But you guys need to make sure and also tell the customers when they select localized core stations or the service providers, and make sure that the net RTK, their service providers, the protocols are the same in this wide screenshots. So for example, if we're talking about like RTCM v3.0, there are many cases that the feedbacks back to us, their protocols is 1003, like 1003 protocols. But actually, DJI Terra started to support from 1004 and 1012. So if it's 1003 from the protocols is 1003 from the localized net RTK service providers, and then you have that
stored in the SD card of the missions and then you import it into DJI Terra, it will not successful to process. So make sure you guys let customer know, make sure the protocols should be always the same. But sometimes this is maybe not very easy to find and maybe not easy to tell, to understand, and to show that to the customer. So in this case, you can simply recommend customer to purchase a DRTK 2.0. So by using DRTK 2.0, the data from the DRTK 2.0 should always be good to process in DJI Terra. It's the same case if you're using the third-party base station. Make sure that protocols are, whether it's the same or above. Okay. So this is really important. It happens a lot. Make sure that when customer purchased L1 sensor from you guys, if they get this error, make sure that you guys know how to detect this problem. So, like I mentioned previously, the reconstruction resolutions, the high it's at original resolutions and media is 1/4 and low is 6.25% of its original point cloud data. And point cloud effective distance to 550 meters, and I already explained the difference by setting up different numbers. Make sure that the greater than the effective distance will be considered as noise, so they will be eliminated. Okay. So the LPP is the like I said, it's accuracy elevation, optimization functions for the edges area. So to optimize the relative accuracy of the point cloud accuracy after opening, the point cloud accuracy will be higher, especially the accuracy of the overlap area and adjacent strip will be improved as well. So this function is paid function and requires permission of professional version and above. So those are some potential causes when you process the data in DJI Terra. For example, when DJI Terra returns to you LiDAR point cloud post data error. So in most cases, that's what I just mentioned to you guys. Make sure that the protocols of their local net RTK services are, supported in DJI Terra. And also, if they cannot determine that information, simply recommend them to use the DRTK 2.0. So in these cases, if customer cannot understand that information, I am strongly recommend when you purchase the package to the customer, make sure you can involve M300 RTK's batteries and battery stations, L1 sensors, and DRTK 2.0. Also, another potential possibilities is the RTK related files in the input path, which is RTK, base station files, and main antenna file. Like I said in the previous page, you see the antenna, there are two. One is the antenna data master, and another one is the slave. Make sure the master file is always there. Or maybe could be like lover arm data, record pull data, like port data, which maybe the RTK signal is bad. Those are all the potential causes for returns to point cloud post data error. And raw data missing or file pass error. So in this case, the input pass leaks of files needed for laser point cloud post processing, including the IMU data, RTK base station data, main antennas, and secondary antenna, ARM data, and laser point files, and radar and IMU calibration files. The most common is that RTK is not open during the flight, so there is no RTK information. So make sure that you guys always remind the customers to turn on the RTKs, or simply use the DRTK 2.0 or third-party base station. Make sure that the RTK information is not missing. LiDAR point cloud raw data error. So like the possible cause is the content of laser point cloud file in the input path is incorrect, which may be caused by copying incorrectly. Sometimes if you forgot to have that file into the correct areas, or simply the SD card couldn't record all the data because the speed is not fast enough. So those are all the potential causes. Another one is some input files in the input path, and they stored in maybe incomplete or in the wrong places or simply missing. So again, if we're talking about the reason, either it's SD card is too slow or missing the base station data, or they copy it into the different directories. So those are the major causes that cause all those errors. So another part I want to touch a little bit is right now we are having, basically right now DJI, we have built up our triangles for the DJI Geospatial Industries and Solutions. So we have the Phantom 4RTK, P1, and L1. So those are some pros and cons. And it will give you better ideas. When should I promote P1? When should I promote L1? When should I promote the Phantom 4RTK to the customers? So of course, the first point is the budget, right? So if customers are really tight in budget, so the Phantom 4RTK is always going to be a good choice for them. And also, if the area is not big enough, it's relatively small, so the Phantom 4RTK always going to be the case. The P1 is that it can actually deliver a better accuracy and much higher resolutions. If we're talking about large-scale mappings, and also if we really care about horizontal accuracies, and if we want to have a 3D models, P1 going to always be the choice. L1 is that if customer looking at, also if we're talking about 2D map, P1 and Phantom 4RTK should be the choice. But if we're looking at real actual point cloud data, and also we're talking about, for example, like point cloud data measurements and analysis in the most of the cases, because I know in most of the foreigner countries that they don't really care about 3D models, but point cloud is the one that mostly apply to all the applications analysis. So if the point cloud data is the key, and also you want to have a real measurements of those points, and also you want to have different return informations to capture, for example, DEMs and those type of things, then LiDAR going to be always the choice for it, okay? Yeah. So there are some couple notes for L1. So L1 currently only supports the M300 RTK to put it underneath of it, so at a single gimbal. It does not support dual gimbals or upper gimbal. So right now, L1 doesn't support dual controllers. They only support a single control mode. Third is during the aerial mapping, you can import DSM to perform terrain follow, but currently the IMU calibration and terrain follow cannot be used simultaneously. So you need to turn off the default calibrate flight button in order to use the terrain follow. Okay. So in this case, that you're gonna perform a manual calibration first, then switch back to the mission planning and use the terrain follow to perform the mission. And last part is the most important part. Make sure that the local net RTK protocol is supported. Otherwise, it will cause post data error. Okay. So those are the brief intros for the L1 parts. So I'm gonna pause here first, and also there are some applications as well. Let me finish the application part, then I'm gonna do a quick pause to answer the questions. Then we can move to the second part with the DJI, which is DJI Terra. So the L1 is the great tool, for example, like applications like topography, infrastructure reconstruction, forestry, and energy and mapping services. So like for example, we are able to use the L1 data and produce the last file and import it to the third-party software to produce like contours and DEMs and tree classifications and etc. And also it's a great tool for detailed inspection, for example, like those really complex, the long pipeline structure buildings like the bridges and things like that.
And this is our new headquarters, DJI Sky City, and we are planning to move to this new headquarters by beginning of next year. So you can see the structures of those point cloud data, and this is scanned by DJI Air1. And this is another example of the factory modeling that all the pipelines and really complex. If you use the photogrammetries, and sometimes it may not give you those high quality results because all lines are really difficult to reconstruct. You need to take care, make sure that you always have the good image overlaps and in different angles. But for L1, it's much simpler. And also, like I said, because the L1 has the gimbal systems, and we're able to do the surrounding flights and capturing the side informations of the structures there. And the power lines is another very powerful tools. Because lines, if you use photogrammetry, one is really spend a lot of time. You need to plan the missions in different angles to capture the images and to reconstruct lines. But for the L1, in most cases, one flat path that you should be good to go to have all the lines ready to go. And those are some sample case studies from our channel partners. For example, like this is the oil and gas pipelines from Argeo with Rosneft. And this is another like oil and gas factories with our Indonesia channel partners, Hello Robotics, and work with Pertamina. And this is from our US channel partners that they work with Houston Engineering and to fly the data to captures and how LiDAR changed their traditional workflow there. So before I move to DJI Terra, so now I'm going to show you guys how DJI Terra interface looks like when I process the LiDAR data, okay? So now I am going to show my DJI Terra here. So questions. Are you able to see my screen of DJI Terra and hear my voice okay? Okay, cool. I'm gonna go back to your questions later on once I show you guys how to do it in DJI Terra. Then we can have QA sessions to answer the questions that you guys have, okay? So first of all, when you open the DJI Terra right now, that's how that looks like. Once you click, for example, like the new, new missions, then you simply select the LiDAR point cloud processing, okay? You can name it as whatever you want it, okay? And those parameters, you can leave it as default. For example, you can let me import the data first, okay? So now I can import L1 data. So I have imported a folder here. So then I can go to my sorry guys, it seems like I unmute myself. Sorry, I accidentally mute myself, but let me show you guys again. So right now, what I imported to DJI Terra is this is the mission folder. So when you open the mission folder, you're gonna see all the raw data, CLC, CLI. LiDAR data, and base station data, RTK data, and ARM data as well, and also the images. So you don't have to import it separately. So simply what you're going to do is in DJI Terra, you import that entire folder into DJI Terra, and that's it. Very simple, right? So once you have that imported, you can select the point cloud densities, high, medium, and low. It depends on whatever you need. So in this case, we're gonna just keep it as high. Then you can always select the, for example, like the coordinate, the output coordinate system. So now I'm going to just leave as WGS84 as default, and you can select that based on your localized information. Okay. So parameters and reconstruction outputs. So parameters, like I said, most cases leave it as default, and optimized point cloud accuracy. You can turn it on or switch off based on your needs. But like I said, if you turn it on in the edge area of every single flat path, and it will have a better relatively accuracy. And annotations is once you finish the reconstructions, you can do the point, distance, and area and volume measurements based on your point cloud data. Then I simply click start processing, and you're good to go, and it will reconstruct the data. And my laptop is, I would say, just a very normal one. It's not a powerful PC. It only has like 1050 Ti GPUs, and now you can experience the efficiency and how fast that we can process the data. And this data is not small, and this data is relatively a large area. It has like almost like 8 GB data inside of it. So we start to process it, and then we can talk about questions and talk about Terra. Then we can go back to the results. Okay, so it started processing right now. Okay, now it's the QA sessions. We're open for the questions that you guys may have. Okay, so let's go through it one by one. Hold on, give me 1 second. So we're gonna go through from the beginning. So again, for now, you guys can hear us and you guys can see my screen crystal clear, right? Okay, let me turn back on to my PowerPoints. So now you guys are able to see my PowerPoints, right? Are you guys able to see my PowerPoints? Okay, cool. All right, so let's go through the questions one by one. We're gonna go through from very beginning, okay? So the first question is, let's see. Yes, that's the common questions, and I answered in the beginning. Once the training is finished, and we will have the materials and ready for you guys, and you guys can download it, share it. Yes, the slide will be available. Will the 6 months DJI Terra Pro license shipped in the demo unit be included all units later also? Yes, it will include in all the hard case of L1. Is it possible to use L1 on the M300 with terrain follow to map facades and flat area in one missions? So yes, but it depends, right? So like I said, you can, when you perform missions in DJI pilots, make sure that you select oblique missions. So in that case, the camera will and the L1 sensor will turn into different angles, for example, like 45 degrees and 60 degrees. So in that case, you're able to capture the facade informations and also the flat area as well. So that will help you guys to capture those information both simultaneously. So the repetitive scan, like I said, it's in this page, and I actually showed to you guys. So this is the repetitive scan mode. So in this case, the area will be repetitively scanned multiple times. In that case, it will give you a better accuracy. Because area is actually cross-compare many times and to give you a better accuracy, and also the FOV for the vertical is also small as well. So in that case, less distortion applied as well. So in that case, when you care about accuracy, make sure that you choose the repetitive scan. And the camera, yes, like I said, the camera is just like the Phantom 4TK, and the camera is also individually calibrated as well.
这里就补充一下，如果他用来上色的话，建议他在 Palette 上开启这个矫正。如果是只是纯图像建模的话，还是 P42，建议用那个原图，用 Terra 会去矫正。你说那个
distortion correction 那个吗？
对，
就开启即变矫正。
如果上色的话，建议就开启。
Okay. And also there are a couple notes because the product manager is with me as well for you guys today. So when you perform the LiDAR missions with the camera on it, so in that case, we recommend that if you guys flew the Phantom 4TK in the past, that you guys may know that one of the functions in the Phantom 4 is called distortion corrections, turn it on or turn it off. So if you're performing a LiDAR missions, we recommend that you turn it on, turn the distortion corrections on. So in that case, DJI are able to process the point cloud data with the true color information more accurately. But if you only use that as the photogrammetry, make sure you turn off the photogrammetry, the distortion corrections as well. Okay. So does L1 only work with M300? Yes, DJI L1 only work with M300. Does L1 support PPK now? Yes, it supports, and I mentioned that in in my PowerPoint in the second parts. So you should already know what I talked about, and if it's not clear, you can type questions again, and I'm more than happy to support. At 50 meters, what level of noise are you getting? So it depends, right? It depends on the weather, on the conditions and lighting conditions as well. But you can referring to the accuracy to our website. So at 50 meters, we're able to deliver like 10 centimeters horizontal accuracy and 5 centimeters verticals. Calibrations. So the LiDAR calibrations, it's really for now, you don't have to worry that because we build it in a very hard ways. So our after sales team will have a later, maybe like a half year later, or sometimes they will give you guys some information about maintenance of the L1 sensor. But for the camera parts, if you use that just to colorize the data, that should be okay. But if you use the camera as the photogrammetry way more oftenly, you can refer to the Phantom 4TK to do the camera calibrations. Will the figure 8 calibration be included in aerial mapping mission planning? Currently, only a linear flight mode will only put the figure 8 in the start and end of the missions. Good question. So actually, we believe that the acceleration and deaccelerations can provide a better and more stable results. So for now, we will have the figure 8 for linear flights and accelerations and deaccelerations for the aerial mappings for different MU calibrations. But eventually, in the end, most likely that we're gonna use the accelerations as our MU calibrations for all the map missions. Why can't calibration flights can be used together with terrain awareness mode? So for now, it's simply not support yet. But like I said, in our next official firmware updates, we will have this feature support. Will terrain awareness mode have a finish mode? Currently, the aircraft has to stop and adjust the height before carry on. No, it will just continues to fly and change the flight height. Currently, that L1 doesn't support live terrain follow, but this is in our future updates, the feature updates list. So we can wait a little bit longer, then we will have this feature ready. But for now, I don't have timeline for this. So 100 second, it's like this, so this question is talking about IMU accuracy. So based on our experiments, 100 second is the ideal time. So after 100 second flight time, you need to perform the IMU calibrations. So in this case, because IMU system, it's actually a system that it will accumulate the air from the beginning to the end. If we always use the constant speed to fly, it will accumulate the air. So it will give you the worst results when you do the reconstruction if you care about accuracy. So that's why after every 100 seconds, we need to whether change the speed or do some different change direction, and we can have fresh and accurate IMU results there. So that's why you need to perform the calibration after 100 seconds. And in this case, like I said, in most cases that we recommend that you fly the M300 RTK with L1 at 10 meters per second. So in this case, after a single flat pass, not adjacent, you need to perform IMU calibration every 1 kilometer. So like for now, you either to perform the calibrations manually after 1 kilometers, or simply you plan your aerial map missions, the single flat pass no longer than 1 kilometer. But like I said, in our next official firmware updates, we will consider, and for our mission planning, we will consider automatic IMU calibrations based on 100 seconds, and also based on your flight speed to perform the automatically calibrations. You can plan a bigger area of the mission. So what is the recommended time to wait for IMU to warm up? Like I said, 5 minutes, but also in the pilots, it will give you a pop-up message like warm up system warm up finished. So you simply need to wait the warm up finished, then you should be good to go. L1 only compatible with M300 RTK. So
waiting times.
Aside from DJI Terra, what other post-processing software the output from L1 is compatible to process? So, like I said, DJI Terra able to have two steps. Step one is the middle step. We can output the raw LiDAR data with the high precision post data. Whoever interested to develop their own algorithms, they can, based on those data, to process their own last file. or simply that they use DJI Terra to process to produce the last file. Once they have the last file, if customers that they need to have, for example, like the DEM contours and classifications, then they can simply import the last file from DJI Terra to third-party software, for example, like TerraSolid, to process it. And in the beginning of July, we will host another webinar, and it's to join the webinar between DJI and the TerraSolid to talk about the end-to-end solutions between DJI L1, Terra, and TerraSolid. Have to do IMU calibration when fly over 1 kilometer range. Yes, if the flight speed is over 10 meters per second, yes, you have to perform IMU calibration over 1 kilometer. The point cloud densities at 90 meters, you can check on our website. It has that information. How frequent the figure 8 calibration should perform? Is it every missions? So I actually suggest that every single missions, not suggest that it actually has to do. You have to do the calibrations for every single missions, you know, beginning and to the end, to make sure that you can always deliver the good accuracy. Terrain follow is always available. You simply import DSM into DJI palettes, then it will based on the DSM information to perform terrain follow. So at this point, there is no way to use terrain follow without having to make and upload a DSM beforehand. Yes. What about the accuracy of X and Y and Z axis? Have you ever checked with checking points on the ground to see the quality of the L1 output? Yes, the accuracy for both horizontal X and Y are within 10 centimeters at 50 meters height, and Z is under 5 centimeters. We have checked it every day. So all the official L1 units, before we actually ship out from our factory, we do massive and intensive tests to make sure that it actually can meet that accuracy. The PPK processing result, like the options that I have introduced in my previous slides. Right now, the output from DJI Terra are not. Right now, the output from DJI Terra are not 100%. You cannot directly import it to the Autodesk. But once you have the OBJ file or point cloud data, you can convert it to the Autodesk supported file. So the point cloud accuracy optimization, like I said, when you perform the flat pass, so every single flat pass that the edges area will have overlap, right? So if we do not have the point cloud accuracy optimizations, the overlap may become a little bit, noisy because there are redundant data. So by having the point cloud accuracy optimizations, it can eliminate the redundant data and it decrease the, the noise, and for the edge areas to increase the accuracy. L1 with M300 need DRTK 2.0 mobile station. If without DRTK 2.0 mobile station, it can post processing. Yes. So like I said, you can always use the DRTK 2.0. You can use the NetRTK, but like I said previously, make sure that your local service provider NetRTK, their protocols is supported in DJI Terra. So it's in this page. So it's in this page. Make sure the protocols are listed on the right side. If the protocols doesn't support, DJI Terra are not able to process this. So you either let customer know, see if they can determine what protocols that they're using for their net RTKs, or if they cannot confirm and determine that information, simply recommend them to purchase the DRTK 2.0 to use it for real-time connections or post-processing, or simply they can also use the third-party base station to do the PBK as well. But again, they have to support those protocols as well. Where do you get a DSM for terrain follow? So you either fly the the P1 or fly the L1, use the camera to capture the images. Then you reconstruct into DJI Terra, select the full tree mode to have that DSM generate. Then you can import back to Pilots to perform the terrain follow. Or you can download it from, for example, the service providers there right now. You can download 30 meters level resolution DSM data globally, for example, from USGS and use that and make sure desampling and also separate a file called TFW file and import it back to Pilots to use it. Yes, you guys will get the training slides later on once I finish the presentation. How to process the PPK? I have introduced you guys into the PowerPoints. So and those are the step by step. And also make sure you can download the user manual from our websites. The user manual has the step-by-step detailed instructions of how to do the PBK using DJI Terra as well. So for the Sky City original data, I need to check if I can share that original data to you guys, but for now I don't have answer. I can check on it. The L1 data cannot process in the cluster version of DJI Terra right now. You cannot import existing loss file into DJI Terra, and also it doesn't make sense.
You can in Powerline mode.
There is only one scenario that if you import the last file into DJI Terra is a DJI Terra electricity version. Then once you import the last file into DJI Terra electricity version, you can based on that point cloud to perform and plan a mission to do the power line inspection. Yes, it will have the screen recording as well. Will it be possible to fly L1 without RTK? Will it be possible to fly L1 without RTK in the future?
现在就可以了。
No, I don't think so. So L1 gonna always have to use the whether net RTK or base station or the PPK methods all the time. Do you mind going over the difference between DJI Terra Free for L1 and versus Terra Pro Electricity? Okay, good question.
So the free version is the one that you simply downloaded from our website. Then once you download it, and you can use that to process the L1 data, point cloud data. But the Pro and Electricity version is simply have the photogrammetry functionalities for the Pro, and also Electricity means that you are able to process the images from Phantom4TK and P1. The free version are not able to process the images from P1 and Phantom4TK. So no photogrammetry, no 2D reconstruction, no 3D model reconstruction. So for the free version, but those are all included in Pro and Electricity version. And also Electricity version, like I mentioned, you're able to, for example, import point cloud data, and based on the point cloud data to perform, a mission, to do a power line inspection as well, using the Phantom4TK. What do you input the coordinates for the base point in the software? So it depends, right? It's really just like, for example, if you're at you want to have a local coordinate system, so simply make sure that the base station coordinate system, whether it's projected or not, make sure that the coordinate system from the base station from the RTK that matched with your point cloud data. In DJI Terra, like here, I already showed to you guys, you can change the coordinate system, output the coordinate system, make sure that it always the same coordinate system. For now, DJI L1 doesn't support indoor building scan. It's not support yet. Yes, DJI L1 work only with M300 RTK. It's not necessary to offer L1 with DJI Terra Pro for started kit. Yes, like I mentioned, when you guys purchase the L1, it will come up with 6 months free trial for Electricity version. Can you go over best method to use DJI base and adapt to a established coordinate and elevation, such as an existing control points? Okay, so in this case, DJI base, which is DRTK 2.0. So right now it only supports WGS84 geographical ellipsoid system. So you have that measured the ground control points. So there is no way that you can change it to pre the measurements. But once you click do the observations and measurements, and you can change it afterwards, and just simply convert it from the WGS84 to your localized coordinate system. When will we be able to use NetRTK mode to perform L1 mission? Yes, but like I said, make sure the localized NetRTK support the protocols which DJI Terra can process. So can you give a comparison of how efficient L1 is to P1 in mapping a building? How much faster? So good question, right? So if we are talking about 3D modelings, for now, I'm still recommend that you guys purchase the P1 for 3D modelings. But if you're talking about, for example, like point cloud modelings, because the L1 can directly measure the point cloud, so there is no need to do the aerial triangulations and generating the dense point cloud. So the timing are extremely fast. So for example, if we're talking about the area, maybe like 1 kilometer per square, city modelings for L1, maybe just to like no more than like 1 hour to have the true colorized data results. But if you're talking about P1, even in DJI Terra, it may cost you like 3 hours around that time, even longer than that. Yes, you can import a KML in DJI Pilot, and Pilot will, based on the KML information, to intelligently generate the mission plannings and to fly. Yeah. Can you do a live terrain follow mission for photogrammetry? No, you cannot do. Also, regarding to the IMU calibration process for a grid mission, the calibration will be done automatically every 1 kilometer. Not yet. So for now, you need to keep in mind if the single flat path, no adjacent flat path, if it's over 1 kilometer, you have to do the calibration by yourself. But in the future, our next official firmware updates, we will have this function built up. So in that case, you can build a larger area, and after 1 kilometer, they will perform the calibration automatically. Yeah, for Germany, I know that there are different height systems, but for now, you can simply in DJI Terra referring to the post data editing to have that constant number add and subtract from the Terra interface. But we'll consider that as well. For the live view measurements, point distance and area and volumes, yes, that will be the future features, one of future functions that we will support as well. For a sales perspective, do other drone LiDAR solutions out there need to do calibration? So is there auto calibration that is done by L1? Yes, this is one of the advantage that DJI L1 can perform. Other systems, they have to do manual calibration all the time and very complicated, but for L1, it's automated. Will there be a vegetation deletion function in the future Terra version? I don't know. This is good suggestions. We can consider that as well. So when the power line has different altitude, what do you recommend to create a flat plane to have the same altitude? Good question. So like I said, and previously I mentioned, you can import a KML, which has the absolute height information. So that will, based on that, to perform a terrain follow. Also, you can simply fly the M300 RTK to every single top of the tower and set the points, and then drone will, based on those points, to do the flights. Pilots right now only support the Android system. If KML is not enough, then you can, like I said, you can fly, first of all, you can manually fly the M300 RTK to each of the tower top and set the points, and then you can do the pilots are able to connect those points to perform intelligently mission planning. The benefits for the LiDAR sensor, like I said, are multiple returns, and you're able to get more surface information and structure informations, and know requirements of the light conditions, and also point cloud data. The measurements on the point cloud data are more direct measurements. For post processing, no, you don't have to manually to do all the required folder, make all the required folder into one folder. It's actually already there. But if you're using like a DRTK 2.0 or third-party base station, you simply need to import that file into that mission folder, and that's it. Yes, we do have some sample data. If you need sample data, please ask your sales rep, and then they can share the sample data to you guys. Yes, you can use NetRTK, like I mentioned, make sure the protocol is support. Do you have to fly with the RTK switched on? Yes, you have to turn on the RTK to do the observations for sure. If you do not have the RTK 2.0, simply purchase one. Or you can use third party to do the observations as well. We rely on to the NetRTK. Can we have third-party base station that will output RANEX? Can we mission will out the RTK on the insert file in post? Yes, you can try. But like I said, make sure that the format is supported. Can you show us how to process the PPK within DJI Terra? There is no really extra step. So what I can show you is right now, hold on, give me 1 second. Like I can show you my screen first. So now I can show the desktop. So for example, if I open the L1, this is one of the mission folder. You see this one is RTB. So that's the base station data. So basically, very simple. Once you have the base station observation data at DAT formats or RANEX or RTCM, simply change the suffix to the RTB. Then you import that file into the mission folder, and then that's it. Then you import this entire mission folder into DJI Terra. Then click to process it, and you're able to perform the PPK processing there. Simple and easy, right? Can I fly without connecting RTK services and use the RANEX file from the base station to process the PPK? Yes, you can do this. What is the main advantage of using DJI Terra for mapping than use DJI pilots? You have to, hey man, you gotta better understand what is the pilots and what is DJI Terra. DJI pilots is the flight control APPs, and DJI Terra is the post processing APPs for L1 and M300 RTK, and Terra can now control M300 RTK to perform the mission. Okay, make sure you understand all the base knowledge of DJI products. Another question is the RANEX frequency. The base station RANEX frequency, it's 1 Hertz. That's enough. The minimum requirement of the base station, I mean the RANEX data, the minimum requirements is 1 Hertz. Okay, so that's all the questions for the L1. Any last minute questions for the L1? Okay, if not, then we can jump to the second part of today's training, which is DJI Terra. But in the end, what I want to tell you guys is that's really important. And you guys has to be confident that right now, the L1 is actually the most complicated system right now DJI ever built. It requires you guys to spend time to learn and to study. Once you guys all have unit on your hands, make sure to test it. If you guys have any questions, make sure that you email us, our local SE, like our local sales, like your sales rep and your solution engineers. Make sure that you can email them, let them know the question you have. But I want to let you guys know is you guys make sure you are confident enough, because right now you guys has the best LiDAR units ever to sell, especially when we consider the level, for example, like people they're using like Velodyne or Lavox and this level of the sensor. Don't let other people tell you a wrong message or promote it in the wrong way. These LiDAR sensors are accurate enough. They can perform very accurate missions and meet the surveying and mapping level accuracy and projects. So other people, other sensors like YellowScan, like whatever, we can deliver at least the same accuracy that they can deliver, even better. And also the integrations and functionalities and user-friendlies were even better products. So make sure that you guys can understand the products. Make sure that you guys are confident enough. This is the best product in LiDAR industry, and we believe this is revolutionary products. So make sure we promote it in the right way. Do not tell customer this is for maybe like a low-level accuracy mission. It's not like that. They can promise the best accuracy, and also the accuracy that we list on our websites. So if you guys have any questions of using it, let us know. But let us make sure that we can fully understand these products and we can promote it in the right ways, and we can change the industries, and we can revolutionize the industry as well. Well, I know the supply could be an issue, but it should be we're solving this problem right now. And this week we start officially taking orders, and your first batch of units should be on your hands very soon. For the handheld laser scanner, for now, honestly, we don't have a plan yet. But this is good features. If we really have a lot demand on LiDAR applications, why not, right? Because one thing that I want to mention is once we have the L1 come to the industry, because the DJI way. We're not like have one or two like sales people or technicians that support one or two group people. We actually don't have that much people to support, and in that case, some other companies like YellowScan and like LiDAR, Green Valley Internationals, and they use the Lavox sensor as well, and they're trying to guide customers that they're better products, but actually not. If you retest it, use it, their procedures are much more complicated and more immature, and accuracy is not reliable as well. Even sometimes that they can deliver the same accuracy. So make sure we are confident enough and we can fight it back. And this is the best products. Okay. So if there is not any new questions, let's move to the second part, which is new functionalities of DJI Terra. Let's keep continuing. So Terra, for the DJI Terra, give me 1 second. Yeah, DJI Terra new features. So the main updates are DJI Terra cluster version and L1 data processing. So those are the main features on the Terra. So what's improved? There are some improvements as well, like 2D DSM, DOM, and 3D reconstruction. Speed increased again 20%, and add PLY format and PCD format to 3D point cloud data reconstruction. And task library support viewing the currently reconstruction task list, and 3D point cloud reconstruction result supporting display by height, and significantly improve the reconstruction speed and accuracy of Aero 3 results for you know, the image system and large scale data reconstruction. So first part, we already introduced you guys the LiDAR processing abilities, and second is the cluster. What is DJI Terra cluster version? The cluster reconstruction refers to supporting multiple computers in the local area network to process the same data reconstruction task at the same time with n computers. The efficiency of cluster reconstruction is approximately n times that of a single machine with the same configuration. So who need it? The customer groups who have high computer configuration and high requirements for the timeless of the data processing. They may need cluster version of DJI Terra. So a few features, the control device and worker device. So the cluster version actually divided into the two parts. One is the control device. One means that one computer, they assign all the tasks to the worker device. So in this case, control device doesn't necessary to have NVIDIA graphic cards, doesn't necessary to be a very powerful PC. You just need to assign the tasks and work. If the control device is powerful enough, they can also take some tasks as well. Then they can assign all the works into the worker device. And Terra engine. So that is the worker device runs the program. When the Terra engine is turned on, a worker device is open and the worker device needs to be opened. So in order, control device can allocate the jobs to them and make sure that all the worker devices that they are equipped with NVIDIA graphic cards, and you know, then they can use the Terra engine to process the results and data. And another feature is the name that we need to explain is called a shared file storage directory. So the file storage directory, that is the control device and all the worker device can access and is used to store the results of the cluster reconstruction, and the directory is generally NAS Terra engine cluster computations. That's where you store and share all the you know, the data from a control and worker device. And local temporary storage directory is the local directory on the worker device, and that used to store the temporary file during the calculations. So the business mode. So when the customer purchased the DJI Terra cluster version, it will come with a base package and also plus the customized number of the worker device. So the base package contains already 3 worker devices, means that you can have 1 master device, control device, and 3 worker device. So the subnode can be ordered according to your user needs. For example, if they need more device, more nodes, then they can simply purchase it. But in some cases that they can just simply purchase the like a base package, which is the 1 master device and 3 worker device. And upgrade renew fee is 10% of the basic package price per year. And no upgrade fee will be charged for the subnodes. And cluster version of functions. DJI Terra currently support all the functions in cluster version. For example, the customer needs 10 nodes, then he needs to purchase 1 base package and 7 subnodes. Lessons are only bundled with the control device. The clustered version only provides offline authorizations. The license is only bound to the master node device. The permissions that supports the number of the subnodes will be configured to the bound master node account, and the subnode computer can be replaced at will. But if the master nodes that you need to change or unbound the nodes, the license, you need to contact after sales team from DJI to do so. So how to set up, and those are the components that you need: the cluster computers, that they have the GPUs and switch, screen, box, where to put those cluster computers, and NAS, a network storage server, and those are the components that you need to set up the cluster version of DJI Terra to work properly. So the computer configuration, the GPU and CPU, you know, its performance has a greater impact on the reconstruction. So it is recommended to use the CPU with the more cores and faster frequency. It is recommended to use the like Intel Core i7 and AMD, you know, the processing, the module, and GPU. Make sure it's only NVIDIA graphic cards, and make sure that it has larger memories and more cores and faster frequencies. We recommend it to use 1050 Ti and above. Okay. Memory. The size of the memory determines the number of images that the aero triangulations can process. Each 1 GB memory can handle up to 400 images. To process it, it depends on the condition of the measurement area. The above data may fluctuate to a certain extent. It is recommended 128 GB and above. Hard disk. The cluster node machine is generally equipped with 1 TB mechanical hard disk. It is recommended to install the solid state the hard drive disk to install the system, and commonly used the software and the data storage is stored by the disk area server. The cluster host generally equipped with the 1 TB mechanical hard disk. It is recommended to install a large capacity SSD to install more software and store some data. Normal operation and use are performed on the host as well. So NAS is used to store raw data, engineering data, and backup data. It is not used for Air3 modeling, like the aero triangulation modelings, and it has low requirements on hardware performance such as CPU and graphic cards, and high requirements on hard disk performance. And NAS, a network disk, is large capacity, fast reading and writing speed, and faster transmission speed, and is recommended for user with more engineering projects. The hard disk had to be at least 10 TB enterprise disk with 7,200 revolutions, and total capacity can reach more than 100 TB. NAS is not required option for clustering, and computer with larger memory can also use the disk sharing to achieve cluster processing as well. And switch. Switch is the 10 GB switch. Is recommended to use the 10 GB switch with more than 24 ports, and a 10 GB optical module can be inserted, which can increase the speed of data transmission. Desk area server are connected with 10 GB net cards and 10 GB fiber jumper, and those cluster nodes are generally connected to them by net cables. Line IP settings: the master node, subnode, and NAS needs to be in the same network. Make sure that you're always in the same network. It is recommended that the node machine can be numbered in order. For example, the node machine number 1 corresponding to the IP address, like this, and the node machine 2 also in the same IP address. And that will make it easier to find. Change the name of the node machine to name that is easy to remember. For example, node machine number 1, number 2, things like that. And line share settings: create 2 new folders on the desk area server. NAS, for example, name them origin data and shared folder. The origin data folder is used to store the original data, and the shared folder is used to store the intermediate files during the reconstruction process. Set above 2 folders as local area network sharing. So if you have the permissions and license of the cluster in DJI Terra, you're going to see this. This means the cluster version of DJI Terra options. You click it and open the worker device, and that's how that looks like. The worker device opens the cluster to rebuild the computing engine and DJI Terra engine. You will see and find the worker device, and after installation, it will appear on the start page, and you can find to open the installation directory If the control device machine also participates into the calculations, the machine also needs to open DJI Terra engine as well. And set the shared folder storage directory for the subnode and the master node respectively. Make sure that the shared folder are the same. So set the shared folder storage directory. It is recommended to set it on the net storage server. Note that the shared file storage directories of the master node and subnodes must be exactly the same. Otherwise, the master node will not able to search for subnode when cluster is rebuilt. And automatically copy the results from the master node. After checking the reconstruction results, will be copied from the net storage server to the master device node. When the check-in is unchecked, the results will only be saved on the net storage server. So enter the reconstruction page, then you will see all the master nodes and all the worker nodes, and it will also tell you whether it's busy or it's at idle mode. And make sure that the algorithm version is always the same. That's really important. Otherwise, it may not reconstruction successful. So new mission. So now you can create a mission for 2D and 3D reconstructions. Once you clicked it and you can process it, you can check the progress on this interface as well. So efficiency compare. So for example, we're talking about like 1,000, 2,000, 5,000 images with the 192 images. GPU, CPU all the same. We're talking about subnodes for a single device. Compared with the cluster, we're having huge improvements. You can check the minutes for single device and cluster.